So, you're building with large language models. These things are designed from the ground up to follow instructions, and that's their superpower, right? But it's also a massive, massive vulnerability. Okay, let's dive into how we can actually defend our AI systems against one of the biggest threats they face, prompt injection.
Look, this is not an exaggeration for anyone out there with a background in web security. That phrase SQL injection, it should send a chill down your spine. And for good reason. It was the attack that defined a whole generation of web vulnerabilities. This quote just nails it. We're in a brand new world with a similar level of threat. We absolutely have to get this right.
So why should you really care? Well, because these aren't just some theoretical problems. An attacker can literally override your core system rules, force the model to just ignore the safety instructions you carefully programmed into it, and even steal confidential data. Just imagine your RAG system, the one retrieving helpful info from your private docs, being turned into a weapon to sneak that exact same content out the back door. That's the risk we're dealing with here.
Okay, so to defend ourselves, we first have to know our enemy. These attacks, they really fall into two main categories. And they might seem similar on the surface, but trust me, the distinction is crucial. We're talking about injection versus jailbreak.
Now, what's really interesting here is the difference in intent. On one side, you've got prompt injection. The attacker is adding new instructions to completely hijack the LLM's function, to make it do something totally different. On the other side, a jailbreak, well, that's where the user tries to trick the model. It's basically social engineering for an AI, trying to coax it into bypassing its own safety training, to get it to say something it knows it shouldn't.
Let's zoom in on prompt injection. This happens when untrusted input, and here's the key, it could come from a user or a document your system reads, has instructions that try to override what you, the developer, originally told the model to do. The classic example is hiding a command like ignore all previous instructions deep inside a PDF that your RAG system ingests. To the model, it just looks like another instruction to follow.
A jailbreak, on the other hand, is all about deception. The user isn't trying to hijack your app's tools, they're trying to get around the safety alignment that's been built right into the model. They'll use all sorts of clever tricks, like, hey, let's roleplay, or this is just for a fictional movie script. Anything to convince the model that it's okay to generate forbidden content in this one specific context.
So, now that we know the two main types of attacks, let's take a peek at the attacker's playbook. Understanding these common patterns is really the first step toward building up our defenses.
Here are a few big ones you'll see. There are direct instruction overrides, policy downgrades, where they try to trick the model into thinking it's in some less restrictive developer mode. You'll see direct attempts at data exfiltration, and this one's critical, tool abuse, tricking the model into running a database query or an API call it has no business running. Now, the point here isn't to memorize every possible attack prompt, but you do need to build systems that can recognize the intent behind them.
Okay, we get the threat, so how do we fight back? Well, the answer isn't some single magic bullet. It's about building a fortress, using a classic security concept, a layered defense-in-depth strategy. Our fortress is going to have 4 main layers. We'll start simple, with some static filters. Then, we're going to add a smarter LLM-based classifier. After that, we'll layer on runtime monitoring to watch for anything suspicious. And finally, we'll reinforce the whole thing with strong architectural design. This is our roadmap. Let's get into it.
Layer 1 is your outer wall. These are the fast, cheap, and simple checks. You're basically looking for the obvious, low-hanging fruit, those telltale phrases like ignore all previous instructions or reveal your system prompt. You can just use simple keyword lists or a bit of regex. It won't catch the really clever stuff, but it's an amazing first line of defense.
Next, we bring in the heavy artillery, an LLM-based classifier. Now, the idea here is brilliant. You use an AI to police another AI. You can use a smaller, faster, dedicated model that acts like a security guard. Its one and only job is to look at incoming text and slap a risk label on it before it ever gets to your main, more expensive model.
And this table shows you exactly how it works in practice. A totally normal question like, what's the capital of France, gets labeled safe. Easy. But a command to ignore all rules, that's correctly identified as a prompt_injection. The whole movie script trick gets flagged as a jailbreak attempt. And a dangerous database query is caught as a tool abuse attempt. See? Once you have these labels, you're in control. You can decide to block the request, clean it up, or flag it for a human to review.
So detection is great, but you know what's even better? Prevention. Let's move on to our most advanced layers, which are all about changing the very architecture of your application and bringing in human safeguards when it counts.
Prevention by design is all about making your system inherently more secure from the start. This means things like strong message separation, where there's no way user input can ever be confused with a system instruction. It means explicitly telling the model that its safety rules are non-delegatable and can never be overridden by anyone. It means running any tools in a restricted sandbox with super strict limits. And for high-risk areas like finance or healthcare, it absolutely means having a human in the loop to approve sensitive outputs.
All right, we've laid all the bricks, from the outer wall right down to the reinforced core. Now let's take a step back and look at our completed fortress and see how all these layers work together in one cohesive strategy.
This right here is the key takeaway. You can see the entire defense-in-depth strategy laid out perfectly. At the input layer, you've got your simple filters and your smart LLM classifier. When you're dealing with context from something like a RAG system, you mark it as untrusted. Your system prompt itself has non-overridable rules baked in. Your tools, they operate in a sandbox with validation. You monitor behavior for anomalies. And finally, for the highest stakes, you have a human review. Every single stage of the process has its own corresponding defense.
And this really just sums it all up, doesn't it? There is no set it and forget it solution here. Security is not a product, it's a process. You need layers, you need constant monitoring to see what attackers are trying, and you need to iterate and improve your defenses over time, always. So, what's the one thing I really want you to walk away with from all this? It's not a specific technique or a piece of code. It's a fundamental shift in your security mindset.
This is so important. Prompt injections are not a bug that's just going to be fixed in the next model update. They are an inherent, natural consequence of building these incredibly powerful systems that are amazing at following instructions. And once you accept that, your whole approach has to change. The only sane way forward is to adopt a zero-trust policy. Treat all external input, whether it's from a user or a document, as untrusted. Period.
So, I'll leave you with this one question to think about for your own projects. After everything we've just covered, take a really hard look at your system. Is your AI's front door unlocked?